In this video, I'm going to go through the investigation task, areas and perimeters, that was on the May internal exam. I'm going to be going through this task in sort of in order, and so feel free to skip ahead to the parts that you are interested in. It's going to be a bit of a long video, sort of going through all the different techniques and the thinking and so on, but yeah, please just use only the parts that you need. So, areas and perimeters. This investigation looks at the connection between area and perimeter of a rectangle. All diagrams are not to scale, right? And the sides of all the rectangles are whole numbers. So that's nice and easy. The area of this 4x5 rectangle is 20, right? Find the area of this rectangle. Well, area is length times width. And you had a nice model there that basically tells you that. So then that's going to be 3 times 10. And so the area of that rectangle is 30 units, right? And you don't necessarily need to worry too much about centimeters or anything like that in this task. Some rectangles have an area of 4. There are 3 ways to write their area, to calculate their area. Okay, so this is not a question. Oops, excuse me. This is not a question so much as it's an indication, right, of the kinds of questions or the model of the kinds of questions that you're going to need to ask later on, answer later on in the task. All right. So it looks like there's different ways of calculating the area. And I guess if we were to sort of analyze this, you've got a 1x4 rectangle, right? You've got a 2x2 rectangle, and you've got a 4x1 rectangle. 4x1, right? You could argue that the 1x4 rectangle and the 4x1 rectangle are the same, but because of the fact that they said that there's 3 ways to calculate their area, they're telling you that the interpretation that you're meant to make in this question and in all the following questions is that 1x4 and 4x1 are different. Or maybe the better word is unique. Okay? So that's like kind of a strong hint, and that's kind of why they do that. So that on this sort of assessment, you're not left asking that question, are they the same or aren't they the same? Because that is up to interpretation. Well, next page. Some rectangles have an area of 6. There are 4 ways to calculate their area. So this question tells you how many ways that you're meant to find. Complete the table to show all 4 ways. Well, they've already given away 1x6. 6x1 is going to be the other one. And then what else has an area of 6? Well, 3 times 2. And then I know from the previous example that I can do that the other way. All right. Question C. Some rectangles have a specific number of ways to calculate their area. Now, so then the question is going to switch and speak specifically about how many ways it's possible to calculate area. There are exactly 2 ways to calculate their area. Complete the table for any rectangle whose area is between 6 and 15. So now we have to think about which numbers between 6 and 15 will only have 2 ways to calculate area. We can see already that an area of 6, there's 4 different ways to calculate it. So 6 isn't going to work. What about 7? Well, we can have 7 times 1 or 1 times 7. And there's no other way for us to calculate 7. And so therefore, there are 2 possible area calculations for 7. Exactly 2. Not at least 2. So there's a few people that put down other numbers and they only wrote down 2 ways to calculate, right? So some people put down 8 and they wrote down 1 times 8 and 8 times 1, right? But then they completely ignored 4 times 2 and 2 times 4, right? So 8 won't work for this question because they're looking for exactly 2 ways to calculate. Other possibilities were 11, 1 times 11, and 11 times 1, and 13, 13 times 1, and 1 times 13, all right. Then the next question, still investigating the same sort of idea, but 3 ways to calculate. Well, the only way, I mean, the ways that we've seen so far, we've seen sort of an even number of methods where you've got this like first set that is the reverse of the other, and the second set that's the reverse of the other. So the only way that you're going to get 3 is actually with a number like 9, where you've got 1 times 9, you've got 9 times 1, but then you have 3 times 3. And this doesn't duplicate because the numbers are the same. 3 times 3 and 3 times 3 would be considered the same, right? Even if I swap those numbers, I'm still getting the same way of calculating the area. And so 9 would be an example of that, right? And that's the only number between 6 and 15 that has that characteristic. Next page is in exactly 2 ways. That was kind of this idea here, right? And specifically, it was numbers like 7, 11, and 13 pages. And we can see that this wasn't necessarily odd so much as it was specifically the number 3. But we could see that 9 worked. And 9 worked specifically because of this guy right here. That there was a combination where the numbers were the same. So essentially, there are more than 4 ways to calculate their area. Complete the table, the area for the number between 6 and 15. Okay, so then I need to choose a number where there's more than 4 ways to calculate the area. I've already sort of seen 6. I've seen 7. I've actually just done 8 on the other page. We just did 9. 10 is going to be similar, right? It's going to be 1 times 10, 10 times 1, 5 times 2, and 2 times 5. So that doesn't really work. 11 we already saw. How about 12? There's lots of ways to calculate the area for 12. 12 times 1, 1 times 12. There's 6 times 2 and 2 times 6. And there's 3 times 4 and 4 times 3. So that's more than 4 ways to calculate the area. We already saw that 13 is prime, and 14 is going to be similar to the others. 1 times 14 and 2 times 7, so there's going to be 4 different ways to calculate it. And then 15 is 1 times 15 and 3 times 5, right? So out of all of the numbers between 6 and 15, right, 12 is the only one that has lots of different ways, more than 4 ways to calculate it. Next page. Go back a couple of pages. So now we're going to examine rectangles whose area is between 1 and 20. List the areas that can be calculated in exactly 2 ways. Well, that's interesting. All right. So if we're examining between 1 and 20 now, we've got a bit of a wider selection. So we know that 7, 11, and 13 will work, right? But why did they work? They worked because there was only 2 ways to calculate it, right? Basically because there's no, other than 1 times that number, there was no other way of calculating the area for that rectangle. So we need to imagine other possibilities. 14 has a couple of different ways, 15, 16, 17 is another one, 19 is another one, if we're going all the way up to 20, and then going down 2, 3, and 5 are ones that we didn't cover either. 2, 3, and 5. And so that would be the list right there. And then it says, write down the mathematical name for the numbers in your answer in part A. These are called prime numbers, because they are numbers that can only be yielded by multiplying 1 and itself. Then it asks you to list the areas that can be calculated in an odd number of ways. Now that's interesting. Again, we're still looking between the numbers 1 to 20. You're looking for square numbers. 9 works. 4 would also work. Technically, 1 would also work, but because it's an odd number of ways, right? 1 times 1, there's only 1 possibility, right? And 16. And then again, they ask us, what are those numbers? And they are square numbers. They're square numbers, specifically because they're going to need that pair where the numbers are the same, or the factors are the same. Let's examine rectangles whose area is between 150 and 200. Find the area that can be calculated in an odd number of ways. Well, unfortunately, I think this problem's answer hinges on being able to discover the answer to the problem above and realizing that we're looking for squares, right? If you realize that you're looking for squares, then it makes that problem a lot easier. And I think, unfortunately, with this question, if people got this wrong, then people got this wrong. You know, if you didn't see that squares were what we were looking for up here, then you didn't realize that squares were what we were looking for down here, which is a bit of a fault in the question. But the 12 times 12 is 144, so that doesn't quite reach the 150 mark, but 13 times 13 is 169. So find an area. So 169 is the area that's connected to the 13 times 13. And 14 times 14 is 196. Again, these are not things that you need to be able to do in your head. You could just do them in your calculator. But those are the two areas that can be calculated in an odd number of ways. And being able to get that is just 1 mark for that question. Be a good idea for you to follow along with the mark scheme while you're looking at this question, just because that'll at least help you see how marks were allocated. All I'm doing is just explaining how the question was done. Next page. All right. So then this question. See, now this is an area where a couple of people got fooled because they didn't quite pick up on the fact that the question had switched and it was now talking about perimeter, right? But again, it's really important to read instructions and just make sure that, we recognize that every single question, especially if there's nothing being asked here, this is like an introduction to kind of give you a sense of like what's coming up and what kinds of interpretations, what kind of framework you should be using for interpreting. Specifically, perimeter. And so they're telling you the perimeter of this rectangle because you're sort of priming you for the next question, right? Not that you can't find the perimeter of the 4 by 5 rectangle, but yeah, it's important for you to be able to pay attention to those things. So perimeter there is 10 plus 10 plus 3 plus 3. And so that's 26. And perimeter here is 9 plus 9 plus 2 plus 2. And that's 18. And 4, 22. Next page. So then this is interesting because it starts looking specifically at the width and the length. So the width of a rectangle, and this is where I would start drawing things out. The width of a rectangle is 3. Its area and its perimeter have the same value. Find its length. Isn't that interesting? Now, down here you've got a bit of a model. So, they didn't give us the length. They didn't really tell us what to do with that. So, in order for this to work, one way that you could do it is you might identify that the length is some variable, right? And then, we know that the area would be length times width. And so if I use the 3 and the x, it'd be x times 3, or 3x. And I know that the perimeter of a shape is 2 times the length plus 2 times the width, 2 lengths and 2 widths. So that's going to be 2 times x plus 2 times 3, which is 2x plus 6. And the area and the perimeter have the same value. So the area is equal to the perimeter. 3x is equal to 2x plus 6. I'm going to subtract 2x on both sides, and I'm going to get x equals 6, which is the length. And then it says write down its perimeter. Well, 3 and 6. 6 plus 6 is 12, plus 3 plus 3, which is 6, 18. 18. All right. So notice what happened there right here. This investigation sort of switches gears a little bit. Now we're using our equation skills in order to solve things. So try not to let that catch you off guard, but it is a little bit jarring and rattling. So they give us another rectangle here. Length is x, width is 4. Write down an expression for the area of this rectangle. Area equals length times width, or 4x. Right? Write down an expression for the perimeter of this rectangle. Perimeter is 2 lengths and 2 widths. 2 x's and 2 4's. Perimeter equals 2x plus 8. The area and the perimeter of the same value, write down an equation and solve it. Now see how this question's kind of asking us to write down an equation. You didn't really need an equation in this question. I think the idea here is that this question could be done with an equation, like I did, right? It could also be done with a little bit of trial and error, right? The width of the rectangle is 3, area and perimeter of the same value, and you could try out a couple of different lengths, and you might be able to find it on your own. But I don't know. I like the idea of finding an equation, structuring the information that's provided in an equation form so that I know that I'm working my way towards the correct solution. So write down an equation and solve it. Well, the area and the perimeter have the same value, so that's saying that area equals perimeter. 4x equals 2x plus 8 minus 2x on both sides. I get 2x equals 8. And then I get x equals 4. X equals 4. And then on the last page, rectangle has a width of 2 and a length of x. Show that this rectangle cannot have the same value for its area and its perimeter. So see how open this question is, but ultimately the other questions that we saw sort of structured the way that we would do this, right? We are going to write down an expression for the area. We're going to write down an expression for the perimeter, 2 length, plus 2 width, 2 x's plus 2 times 2, which is 2x plus 4. And then it cannot have the same value for the area and the perimeter. So actually, I'm going to do this the same way. I'm going to do area equals perimeter. I'm going to do the area expression equals the perimeter expression. And it seems like, oh, hang on a second. That's the wrong way to do this. But it's not a bad way to do it, because essentially it's the same structure that we've been working before. And if this doesn't work, I should find some sort of contradiction. Well, I'm going to subtract my 2x on both sides like I did before. But what happens is I get 4 on this side, and the 2x minus 2x over here, I get 0 on this side. And what do I have in front of me? I have a statement. Oh, sorry about that. I have a statement that's not true. 4 and 0 are not equal. All right? Therefore, A cannot equal to P. This is my assumption. This is my assumption. And so if it leads to an equation that does not solve or leads to an incorrect expression, then that assumption must be wrong. Right? So notice that I've used the equation to get to what's called a contradiction, And I've been able to find the answer to that last question.